Hello, this is Erin Fogarty. This is my project for EENG 311 Communication Systems Oral Communication Project. Today I'll be discussing fiber optic communication, what it is, what it's used for, and how we may see it used in the future. So fiber optic communication, what is it? It's a method of signal communication or signal transfer that uses pulses of light or photons to carry energy rather than a metal wire and a electric current. You'll see something in fiber optics will be made of like silica glass rather than copper wire, which has many benefits that we'll discuss in a minute. Because of these features, it's very good for long distance or high performance data networking. There are two types of cables that are used for fiber optics. You have what is known as single mode and what is known as multi-mode. And the differences in the way light is reflected within the wire and the sizes of the wires kind of change the benefits of fiber optics from where they could be like used better for long distance or better for large amounts of data transfer at one time in a short distance. We'll go into this here in a second. So what are some benefits of fiber optics in general? So fiber optics have much higher bandwidth than signals passed through metal cables. So because these signals are transferred at frequencies as high as 10 to the 14th hertz, you're allowed to transmit much more data at a single time than if you were to send data through a copper wire. There's also less interference from external sources. That is because a energy carried by a photon is not going to be emitting an electromagnetic field like a current would. So there's not going to be any interference between the electromagnetic field of one signal and the electromagnetic field of another signal. It's also noiseless, which is because of the total internal reflection inside the cable. So the signal is gonna be more pure when it reaches the other end of the transmission. It's secure against cyber attacks. It's also very rugged and flexible. It makes it very good for military applications. It can handle more heat variation because there's not any high voltages or currents being applied to the line. And it's also small and lightweight. So the components of a fiber optic cable are a typically silica glass fiber core, a silica glass cladding. These will have different dopings that will change the way the light reflects within. But you can also use plastic, but most of the time it's going to be glass. Then you're going to have a buffer tube, which would be here, and a jacket, which would be the outside protective layer. So single mode fiber optics. This one is typically used for long distance applications. That's because it has a smaller diameter inner core. This will reduce the attenuation, which means that signal strength will be maintained across the line. So you're less likely to have reduction in light power. It also isolates the light into a single beam. And this is why we're typically going to use a laser because all the light is concentrated and like in phase. And it will give the user more bandwidth, which also means that it will be more expensive. But this one's very good for like transmitting internet or TV cable signals across long distances. Multi-mode fiber optics are better for shorter distances because they have a wider diameter, and the light signals within the cable are going to reflect and bounce more, which will lead to more interference, but you're going to be able to send more data through the cable at a single time. So more data transmission is going to lead to the possibility of interference and loss. It's typically going to use an LED source because the light is not directed in one direction, and but it's very good for getting large amounts of information quick. So here's just a picture demonstrating the filters. Up here at the top is going to be something more like a multi-mode filter, and you can see how there are multiple waves of light bouncing around within. And then down at the bottom is the single mode, and you can see how the light is very direct. So some common uses for fiber optics are computer networking because of its security and its capability transporting large amounts of data very fast. Internet or cable TV. So long distance connections are very secure. You're not going to have many errors in signal transmission. And then medical instruments so are very good as temperature sensors, especially for biomedical applications, MRI scans, or other imaging software or surgeries. These are very beneficial technology for that. So it can also be used in power transmission, and we'll see that if you use it in conjunction with a photovoltaic cell, you can convert light pulses into electricity. And this also goes back to using it for medical applications, because when you're trying to power a machine like an MRI that has a high powered magnetic field, and you don't want to use any conductors or large conductors in the area to produce electricity, that makes the silica glass composition of a optical fiber work very well in transmitting electricity to the system from a photovoltaic cell. So for the future of fiber optics, it is predicted that the industrial growth rate could reach up to 8.5% by 2025 because of its reliability and power quality. It could grow by more than $2 billion over the next 5 years, according to NAI. Also, it's used for many cool applications. San Francisco is creating a citywide network as a way of treating internet like a public utility. So instead of internet being provided by private carriers and being something that people have to pay for or see as a privilege, it could be public access internet that's quick and reliable for the entire city, which is a very neat concept. And it also aids the expansion of new 5G wireless technology, which is also very cool information and technology that we could be seeing in the next few years. So that is the end. Thank you, and enjoy your fiber optic communication.